Hi everyone. Today we are going to discuss about happens before in Java. Okay. So it's a rule in Java memory model that defines when one thread's changes are guaranteed to be visible to another thread. Means if A happens before B, then all memory writes done in A are visible to B. A is executed before B. So this is a rule. It's a very important rule in Java. So we are going to this particular rule in detail today. I will demonstrate some examples as well. So why do we need happens before? So in multi-threading, each thread can have its own cache variables. For example, thread 1 can have integer a and thread 2 can also have a copy of integer a, so that in thread 1 a can be 0, in thread 2 a can be 1 at times. So this is an issue when we are running multiple threads at a time. So these all are happens if you are not handling this happens before properly. So there are multiple ways to solve this problem. So I will go through each and every solutions with examples. So first I will demonstrate the issue without happens before. So when we are running this program, we have a main memory, heap memory, right? So in heap memory, we will be having CPU cache for thread 1 as well as for thread 2. So thread 1 is having the stale value, thread 2 is having the updated value. Means thread 1 is not getting the updated value. So in this example, this flag second thread is making the flag equal to true. But the first thread will never get to know that flag is equal to true. It will always getting the value flag as false. So this is the scenario with the happens before if you are not using happens before in a multi-threaded application. So without happens before, thread A writes x equal to 10, thread B reads x, but it is still getting 0. It is not getting 10 because thread A have its own CPU cache, thread B is also having its own CPU cache. Thread A have a local copy of x, thread B is having a local copy of x. So both are having different values. So with happens before, how it is working. So with happens before, you can see thread 1 or 2 will not keep a local copy of the variable. Instead, it will write into a common location. In main memory, it will directly write to the main memory, not its cache. So what happens? How can we achieve this? In this example, the same example, you can see I have used volatile keyword while declaring the variable itself. So instead of static boolean flag, I written like static volatile boolean flag. So this volatile keyword is making sure that the value will be getting correctly to all the threads. Since the volatile keyword maintains the variable in the main memory, threads will not keep it's in the cache. All threads will directly access from the main memory. So this is how we can solve the happens before issue, or how can we achieve the happens before with the help of volatile keyword. In the second, so this is the same example only. Thread A, thread B writes x equal to 10, read x will get 10. So this visibility and ordering is guaranteed here since we are using volatile keyword. So another example is with the synchronized keyword. So synchronized keyword, if we are using, what will happen? it will lock and unlock, right? Whenever one thread is using that particular method, it will lock that method, then after its use it will unlock the method. So at a time only one thread can access this particular method, so that we can ensure concurrent updates will not happen, that will not cause an issue. Multiple threads cannot update simultaneously. Instead, they have to wait to get the method unlocked, until then only they can access that method. Once they acquire the lock, then only they can update the count equal to plus plus. So here it will work very smoothly. The plus plus will count will return count as 1 when another thread is accessing this get count. So this is very efficient and synchronized keyword you can use for this solving this happens before issue. So happens before will happen very smoothly here. Here you can see the example is locking, then it's writing, then it's unlocking, then another object thread B is reading, so it is getting the correct value, count equal to 5. So thread start, it is also making sure this happens before is working correctly. So here you can see a thread T is created, it is printing the value, then value we assigned equal to 10. So when we are running the thread, it will make sure value equal to 10 executed before starting the thread. So this is the ordering is ensured here. It should execute value equal to 10 first, then it will create the thread and start. So this is how happens before is working in thread.start. So this will always print 10. It will not print a 0 or any other value. So here another example, you can see value equal to 42 is assigned, then thread started, then new thread started, it gets value equal to 42 correctly. So this is how it is working. So here the order is very important. So JVM ensures this order is happening, order of execution, so that it will get the value correctly. It will make sure value equal to 42, the assigning part will execute first, then only it will start. So thread join also will make sure this is working correctly. Okay, so you can see value we assigned as 0 first, then inside thread we are setting it into 100, then we are calling start as well as join, then we are printing the value. So it will always print 100 because this is working in the correct order only. It will not print 0 at any time. It will always print 100. So this is a diagram how it is working. So the thread value equal to 100 executed first, then that thread ended, then happens before is implemented here. So read value as 100, then t dot join returns, it will get the value equal to 100. Final variables everyone knows is constructor. We are initializing this particular variable in the constructor so that it will get updated correctly when we are creating the object itself. Then we have atomic classes. So this is an example of atomic integer. Similarly, we have atomic long, atomic boolean. So these all are comes under Java util concurrent atomic package, so that it ensures the concurrency and it is ensures that happens before and safe to use in the multi-thread applications. So in the initialization part, you can see count we are setting as 0. Then this atomic integer have an inbuilt method increment and get. So if you are calling that method, it will increment it to 1, and when we are printing it, it will print 1. So atomic integer is not using synchronized, but instead it is using volatile and compare and swap technology that we can cover in another video. So this atomic integer is also ensures this happens before. So this is a transitive guarantee is there, means if A happens before B and B is happening before C, means A happens before C. That is transitive, right? A happens before B, then B happens before C, then means A happens before C. So transitive guarantee is there in happens before. So in executor service or parallel execution, how it is working. So that is taken care by this class itself. It will, whenever we are submitting a task, it happens before run. So this is in executor service we are mainly using to run parallel execution, right? Multi-threading. So it is handled automatically. We don't need to take care it separately. So in summary, you can see thread A happens before thread B. So write happens before read. And we can achieve this using volatile, synchronized, start bar join, atomic classes. Now I am going to some examples. So first I am showing without happens before what will happen. So you can see this program. Here you can see I have declared x, y, r1, r2. So this is an indefinite loop. Here I assigned it equal to 0. Then in one thread 1 assigning x equal to 1 and r1 equal to y. Thread 2 assigning y equal to 1, r2 equal to x. So we are starting both the threads and then we are joining both the threads. Then we are checking at any point of time r1 and r2 equal to 0. Means it's an indefinite loop, right? Infinite loop, right? So infinite loop, it will keep on running, and at any point of time if this assigning is not happening, means it will print this reordering observed. Otherwise it will print correctly r1 equal to r2. R1 and r2 the values we will means it is not 0, it is getting updated from here. So this is an example for without happens before what happens. So I will run this and see. Here you can see this values updated. In many of the cases values got updated, but at one point of time r1 and r2 both are 0, means it went here r1 equal to 0, r2 equal to 0. So an issue happened here, right? Because we expected thread will update the value, but it didn't happen since both thread having the local copy. So at times this issue is coming. This is an example. If we are not using happens before, it will fail once in a while if we are executing the program. It can happen frequently or it can happen rarely, but it will happen sometimes. Okay, so if I am using how to solve this, I can add a volatile here. Okay, if I am adding a volatile, and I am running, what will happen? It will keep on running. It will never stop because it will never comes to this particular condition r1 equals 0, r2 equals 0, because it will make sure always these values are updating to the correct variables. So it will never come. So I am stopping this application manually. So this is an example for happens before, with the happens before and without happens before. So if you want to see more examples, I can show you one more example, atomic example. Okay, this is atomic example. This is simple. This is if you run, it will print 1 always. This is not multi-threaded, but if you are using in multi-thread application also, it will print correctly. multiple threads, if multiple threads are using count, increment and get, whatever the latest value will get to the all the accessing threads, because get means simply getting, increment and get means count plus 1 it will do, then get. So this is how the atomic integer works. So atomic integer also inbuilt thing in Java. It comes under Java util concurrent atomic integer. So this is atomic package having many other variables. Similarly, you can check it here: atomic dot, atomic integer, atomic boolean, atomic long, atomic integer array. So depends on your use case, you can make use of any of these. So that's all about this happens before. So there are many other things I want to cover regarding this concurrency and all, atomic integer, how it works, everything. So I am planning to cover it in another video. So thank you for watching this. If you like this, please like and subscribe, share it with your friends. Thank you so much.